mighty four-lane Portillo Bridge. Yet the growth of this metropolitan area has been so great that the cheering turned to grumbles of protest in barely 20 years. It was inevitable that improvement of the Trans-Canada Highway through the Lower Mainland should feature a new crossing of the Fraser, a modern structure unique in North America, to be known as Port Mann Bridge. In 1957, the British Columbia Department of Highways commissioned the firm of CBA Engineering Limited as consulting engineers to locate, investigate, design and supervise the construction of what was to be the last major river crossing of the Trans-Canada Highway. Engineers made test borings at the site and they discovered trouble. Initial investigation was made by means of wash borings and static cone penetrometer tests. A typical test on the south side revealed the discomforting story. From ground level to a depth of 50 feet, the material was of low resistance and high compressibility, mostly peat layers with some silt and clay. From 50 feet to about 120 feet, there were sand layers of varying density. Then the bad news. The test drill entered a deep layer of sensitive marine clay and silts, an unstable material, given to erratic remolding. Even when the findings were good, they were far from perfect. The compact glacial founding layer discovered below 190 feet was overlain by a layer of open-work gravels and boulders subject to artesian water pressures. To complicate matters even further, the elevation of the till surface was uneven. But the sensitive clay was the real enemy. Its unsavory properties can be demonstrated. In the natural state, it's harmless enough looking, but subjected to shocks or vibrations, it tends to become fluid, to reconstitute itself. In its new state, the clay offers less support to the layers above it. Drastic settlement may result. The foundation piles would then be forced to support not only the weight of the bridge structure, but in addition, a considerable downward frictional drag of sand. In all, the engineers drilled 84 holes across the bridge site. They made penetrometer tests, 40 feet either side of the test holes, and they found they were going to be plagued with a sensitive clay at varying depths all across the river. Armed with this information, the engineers began designing the foundations. The bridge foundations were the biggest single obstacle to the successful bridging of the Fraser River. Foundations that must go down more than 200 feet in some locations, 5 critical foundations on the south shore, 2 in the river, 7 massive penetrations of a sensitive marine clay so unstable that a hammer blow or a high-frequency vibration might cause it to remold. The rest would be relatively straightforward.